Welcome to This Explainer. Today we're exploring the awe-inspiring Great Green Wall of Africa and uncovering the hidden planetary mechanics of our Earth's water cycle. I am absolutely thrilled you're here, because we are going to combine a massive geopolitical environmental project with some truly cutting-edge Earth system science. We're going to look right past what we can easily see and really understand the invisible forces that actually keep our ecosystems alive. All right, here's our roadmap for today. We're going to cover 1. Africa's Great Green Wall. 2. Progress, promises, and problems. 3. The invisible water cycle. 4. How plants create rain. 5. Governing the unseen water. And finally 6. A new regreening paradigm. Let's dive right in. Section 1. Africa's Great Green Wall, a continent-spanning ambition. So we begin with this staggering vision adopted by the African Union back in 2007. Imagine a massive green buffer meant to stretch a mind-boggling 7,775 kilometers from Djibouti in the east all the way to Dakar, Senegal in the west. It raises a fascinating ultimate question. Can planting a 15-kilometer-wide mosaic of greenery actually halt the expanding Sahara Desert? It's a pretty bold premise, kind of treating the desert like an invading army that just needs a physical barricade to hold the line.
Now, this idea isn't exactly new. It actually evolved from a 1950s British explorer named Richard St. Barbe Baker. He made a massive expedition across the Sahara and proposed a green front buffer. Well, the idea sat dormant for decades, until it was officially approved in 2005 in Burkina Faso and then formally endorsed by the African Union in 2007. And importantly, it evolved. It started as just a literal wall of trees, but it quickly shifted into a highly integrated multi-sectoral initiative. We're talking water harvesting, protecting indigenous greenery, and rural development, the whole shebang.
The sheer scale of this ambition is mapped out in its 2030 goals. Originally conceived as an $8 billion project, it seeks to fundamentally improve food security and mitigate climate change by the end of this decade. The targets? Restore 100 million hectares of degraded land, capture 250 million tons of carbon dioxide from the atmosphere, and crucially, create 10 million rural jobs in the process. It's not just an environmental project, you see. It's a massive socio-economic lifeline for the entire Sahel region. Section 2. Progress, Promises, and Problems. Let's look at the reality on the ground. As you can imagine, implementing a project across over 20 sovereign countries is incredibly complex. And when we look at the data as of 2024, we see a pretty sobering picture. About 30 million hectares have been restored. So that means only about 30% of the 100 million hectare target has been completed. Now, while 30 million hectares is still a massive achievement, for sure, it really highlights a very slow progression relative to that looming 2030 deadline. And this brilliantly illustrates the disparity on the ground. Success is highly uneven. Just look at this contrast. Ethiopia has been incredibly successful, reclaiming 15 million hectares and planting a staggering 5.5 billion seedlings. But then you look at a country like Chad, which has only managed to plant 1.1 million seedlings. The reality is, international donors tend to favor investing in more stable nations, leaving those with fragile governments way behind. In fact, the project currently faces a critical risk of collapse. It's battling severe insurgencies and terrorist threats in places like Sudan and the wider Sahel. There's also an absence of domestic political leadership. As one environmental activist from Niger pointed out, Sahel countries haven't really allocated their own budgets for this and are simply waiting for foreign funding. And speaking of funding, the estimated need has ballooned to $33 billion, plagued by unfulfilled international promises and really poor coordination.
Section 3. The invisible water cycle. Shifting the paradigm.
Now, to understand why regreening struggles in these dryland regions, we must shift our perspective. Drawing from a fascinating academic thesis by Sophie Anna Tawerik, we have to move away from the concrete reality of simply digging holes and planting trees to the abstract, unseen machinery of the earth. Think about it. If you want a massive wall of vegetation to survive in a fragile environment, you have to understand the invisible water that feeds it.
To do that, we need to define two absolute game-changer concepts: green water and atmospheric water. Green water is the water stored right there in the first few meters of the soil. It's the moisture directly available to plants to produce biomass. Atmospheric water, on the other hand, refers to all the water in liquid and gaseous form up in the sky deriving from evaporation and transpiration. These two completely overlooked types of water are inextricably linked to the land and are literally the foundation for food production, climate regulation, and carbon sequestration.
So the crucial point here is this deep water divide in how we manage our planet. Throughout history, humanity has fiercely regulated visible blue water. That's your rivers, your lakes, your groundwater. We build dams, we write international treaties, we literally fight wars over blue water. But we completely ignore the invisible green and atmospheric water. It is largely ungoverned, sitting in this massive blind spot that cuts across forestry, agriculture, and climate policy, yet it actually sustains our ecosystems.
Section 4. How plants create rain. The mechanics of moisture recycling.
Okay, get ready for a mind-bending revelation from the Earth's sciences about how the African continent actually gets its rain. An astonishing 33 to 50% of the rainfall over the African continent is created entirely by vegetation-driven moisture recycling. Let that sink in for a second. Up to half the rain isn't just blowing in off the ocean, it's being actively generated by the plants themselves.
So how does this work? Through the beautiful process of the eco-hydrological cycle. Step 1, vegetation absorbs that invisible green water from the topsoil. Step 2, the plants release it back into the sky as atmospheric water through a process called transpiration. Step 3, that moisture travels on the wind and falls as rain somewhere else, perhaps hundreds of miles downwind. It's like a giant puzzle. Trees and non-tree vegetation act as a massive, continental-scale water pump, taking moisture from the soil and gifting it to the sky.
Section 5. Governing the unseen water. Rules for the Anthropocene.
Understanding this immense power means we must figure out how to govern something we cannot physically hold. This really powerful quote from the late Earth system scientist Will Steffen perfectly captures the heavy responsibility of our modern era, an era known as the Anthropocene. We now have the knowledge of how our land use changes the sky. Because water is facing a global squeeze from climate change and overuse, we have the responsibility to govern these invisible flows before we push the Earth system out of the stable conditions that have allowed human societies to flourish.
But right now, we are severely lacking. The research identifies 3 main governance gaps. First, international water law is highly fragmented and completely overlooks explicit governance of green and atmospheric water. Second, most of our understanding of moisture recycling is skewed toward wet tropical regions like the Amazon, leaving us poorly equipped to understand drier regions like the Sahel. And third, we failed to anticipate how local land use changes, like say planting a massive forest, affect distant rainfall at multiscalar levels.
Section 6. A new re-greening paradigm. Let's bring it back to the wall.
Let's connect these cutting-edge hydrological concepts directly back to the Great Green Wall. To succeed in the Sahel, we cannot simply plant trees blindly and hope for the best. We absolutely must integrate new rules for re-greening. We have to account for the net water use of trees, ensuring we aren't draining scarce local water resources. We must deeply understand the hydroclimatic landscape before a single seedling goes into the ground. And we must anticipate the heterogeneous impact of different vegetation types on moisture recycling, recognizing that not all plants contribute to the water cycle in the exact same way.
The ultimate takeaway of this explainer is that ecological restoration is a double-edged sword. Large-scale regreening can either intensify the continental water cycle, generating more rain and net water availability, or, if done poorly, it can severely aggravate local water scarcity by literally sucking the soil dry. Without a coordinated framework to manage these invisible resources, our best, multi-billion-dollar environmental intentions might completely backfire.
Which leaves us with this final, profound thought. If a country plants a forest, and that forest pumps moisture into the air that falls as rain in a neighboring country, whose water is it? If trees control the rain, who actually owns the clouds they create? It is a profound legal and ethical puzzle for our generation, leaving us to wonder exactly how we're going to adapt our laws to govern the very sky above us. Thank you for joining me on this explainer. I really hope this completely changes how you look at a forest, a desert, and the rain.